Hello guys, my voice is audible to you?
Yes, sir.
In the last lecture, we saw the application, the first application of maxima of derivative, and the topic was optimization, which we generally call maxima or minima. And we also saw the mathematical condition which lead to the correct answer about the peak and valley. We discussed about something called local maxima or local minima. We are not concerned about the absolute maximum or absolute minimum. We are only concerned about the place at which we have either local maxima or local minima. So the peaks and valleys of a equation can be found easily by differentiating the function and equating to 0. But to distinguish between the peaks and the valleys, the method was differentiate 2 times, right? That's called the double derivative. And upon differentiating 2 times, we substitute the critical points value that we obtained using the first derivative, and we check for sign. Okay. So for maxima and minima, I would say for maxima or minima. So for maxima or minima, what we can write? The first derivative of the function must be 0. And then this will give you, because you differentiate a function, you get another function of x, and the x will be 0. Let's say this answer is 0 at point x1, x2, x3. So what we do is we check. So for maxima, we differentiate twice, and we put x equals to x that we have got. And if at a given value of x, if the second derivative turns out to be negative, so for maxima, if the second derivative is negative, then at x equals to xi, we'll have local maximum. And for a minimum, what we do? So for minima, the second derivative must be positive at a given value of x. Let's go xj, then at local minima. Okay. Now, when you solve any equation, the solution to the equation called this, all these xi are called critical points. So these are called critical points at which there is a possibility of either local maximum or local minimum. So how we solve question of maximum and minimum? So generally the trend is you first find the relation. So how to solve question of maximum or minimum? The rules are very simple. So the first step is first try to understand. So first try to understand what you want to either maximize or minimize. That's you have to understand first. Choose suitable variable to express the physical quantity you want to so express you choose the suitable variable to express the physical quantity you want to maximize or minimize. Now, every time when you try to solve a question of maxima or minima, there is some constraint given to you which you cannot change. So let's say if you want to design a dress, I mean, a cover of some geometrical shape object. So you go to market and you buy a piece of cloth, and now using that piece of cloth, you try to cover it. So the piece of cloth will have the finite area. So that's area is like a constraint to you. Let's say you want to tie someone with the help of a rope. So you go to market and you buy a rope. So you always buy a piece of rope with finite length. So the length of that rope is like a constraint. So you have to understand what is my constraint in the problem. Like what I cannot increase or decrease. What is I have in limitation. So that is why we say try to understand the quantity which can't be changed. So such quantity is called constraint. So that is your step 3. The step 4 is what? So always express the value you want to maximize in terms of some variable. So step 4 is write y as a fx. If you have taken multiple variable to express the answer, try to eliminate the variable till it becomes single variable. So write y equals fx, and then step 6 will be find dy by dx and d2y by dx square. Put Okay, so you can see these are the things that you need to remember. I hope this is clear to everyone.
Yes, sir.
Yes, sir.
So you can read these steps and try to formalize in your brain, and then we'll start the problem solving. So read for a while till it makes some map in your brain, then I'll start. Then if you're done, let me know.
Done, sir.
So let's begin some question. So let's say a particle is thrown from the bottom. It goes on a curved path like this, which we call parabola. And the y represents the height of the particle. So you can see clearly the height will vary as x will vary, yes or no? Correct? So as the x will change, the height will change. I hope you can see that. So there is a clearly visible point which we can call maxima. Yes or no? And at this point, what will happen? At this point, the slope becomes 0. Now this will not be given to you, rather than what they will give you. They will give you the height of a particle in its journey. You can call it y. So if y represents height, the height is written as, or written by the formula ax minus bx square. Let's call this formula representing this curve. You want to know at what value of x the maxima will occur. Okay. So now the equation is given to you directly. So when equation is given to you directly, then all the steps are redundant. You start from here. So the step 4 is given to you. So if you start from step 6 and keep on solving. So what is the first step for you? Differentiate the equation 2 times with respect to x. So dy by dx will be how much? A and b are constant. So what is dy by dx? Tell me.
A minus 2bx.
And what we do? We equate this function to 0. So once you equate to 0, what will get?
A by 2b.
So putting dy by dx to 0 is like putting some equation to 0. So we what we get is the equation, and the x turns out to be. And how many values you got? Only one value. So either one maxima is possible or one minima is possible, because we don't have much options. So the number of x will tell you the number of peaks and valleys. So how many peaks and valleys are possible here? Can we say just one? So peaks and valleys are just one, only one value. But let's say if graph is not given, if you don't know that this is the graph, then how to solve it mechanically? So the next step is, once you differentiate, don't stop, differentiate once more. So the second derivative will give you what? Tell me. The second derivative will give you how much? Like differentiate this function, that's it. Once more. What will you get? Come on, tell me.
Minus 2b.
Minus 2b, excellent. And luckily there is no constant, there is no variable here, just value. And we know b is what? A positive number. So minus 2b will be positive or negative?
Negative.
Negative.
And if the second derivative is by default negative, it represents what? Maxima or minima?
Maxima.
Maxima. Which means at this location, the maxima is present. So now this is proof that, therefore, at x equals to a by 2b, we will get maxima. Very good. Simple. The other question that may ask you that if that is the location at which the maximum is there, what is the maximum height? What is h max? So we have the formula h max is y value, or you can say h max is basically f of x when x is a by 2. So what is fx given here? Ax minus bx square. Correct? So here fx is given to us, right? Already ax minus bx square. So to get the value of maxima, how maximum is the maximum, we have to substitute what? X equals to a by 2b. What we get? A into a by 2b minus b into a by 2b whole square. And what is the answer? A square by 2b minus a square by 4b, right?
Yes.
How much is that? Do you know subtraction? Who will tell me the subtraction? First answer will tell. What is the answer? Tell me. Are you there, Prasansha?
Yes, sir.
What is the difference?
Sir, A square by 4B.
That's the right answer. Excellent. So do you realize the meaning of H max? The H max, graphically, you can think what is the height of the graph, the peak or the value. And X is giving you the location at which you can see the peak or the value. So whenever the function is given and we know the location, we can substitute in the function, we get the maximum. We have solved this question using quadratic in the past. Now we are solving using calculus. Is this clear? Is this clear, guys? Tell me.
Yes, sir.
Yes, sir.
All right. So let's do the next question. So let's say now it is a pure mathematical function. You can think mathematically. So in one dimension motion, let's say you're driving your car your typical Mercedes Benz. Okay. So you're driving your car and the displacement from the origin, if I represent at as a function of time t, this looks like minus t square plus 2t plus 3. Okay, so you're trying to go towards the right, and this is the displacement as a function of time. This is not this is the position as a function of time t. So better I can call it position x. I want to know at what instant of time the x will be maximum. Why I'm asking this question, first of all. So technically what is happening, if you realize that this is the case of deceleration. So the person which is driving the car, I mean, theoretically it will go forward and will come back. So at only one particular value of x, it can go, and then beyond which it will cannot go. That's why this x will have some maxima. Now this I'm saying because I know the answer. But anyone who is not aware of this situation, he still can get the answer mentally, I mean mathematically. So here x is a function of time. So you must differentiate with respect to what? The input variable, right? So dx by dt. And you will also find the d2x by, because you're trying to maximize what? X. And it is depending on what? Time t. So time is like a giving you the location. So at one particular t value, this will happen. So let's figure it out. Dx by dt is how much? Tell me, guys.
Minus 2t plus 2.
And what is the second derivative? Let's do the derivative first also.
Minus 2.
Which is negative. So now, if you equate this to 0, if we equate the first derivative to 0, what will get? The value of t?
1.
So which means at 1 second, the x will already achieve the maximum value, right? Which is obvious from the second derivative test, because at the second derivative is negative, which means the only maxima is possible. So what is the farthest point you can reach? What is x max? We know the location. At t1, x will become maximum, right? So at t equals to 1 second, x equals to x max, isn't it? Do you realize this?
Yes.
So what is the maximum value?
So is it 4?
So let me substitute. It's minus 1 square plus 2 into 1 plus 3, which is 4, is the right answer. 4 meter is the, let's say if this is in meters, so 4 meter is the maximum distance you can go. Okay. I hope this is clear.
Yes.
So this was given no at t is equal to 1 second.
No, you got it. No, you got it here.
Oh, okay, sir.
You solved to get got to know, okay, that at what time this is going to happen, and then you
Yes, sir.
realize this. Okay. All right. So let's say it is given to you that the sum of two numbers is, let's call the, okay, so you let's take some real life number. So you go to market and you buy a piece of rope. So length of rope is L. So you can neither increase the length nor decrease the length. So you have to consume the entire rope. Okay. So find the dimension of rectangle that can be enclosed by the rope and have maximum area. So the goal is clear. What we are trying to maximize here? What we are trying to maximize here? What is the goal here? Tell me, guys. Goal is to, hello, am I audible? Tell
Yes.
me, what is the goal here?
So to maximize.
To find the maximum area.
So we want to maximize the area. No? What is the constant here? Constant?
So the
What is the
dimension
constant?
isn't given.
The length of the rope is your constant. You can use the length to make a You wrap around a rectangle. Okay. So with L length, we can draw a rectangle like this, like this. So keeping the same length, we can draw multiple types of length. Correct. So we have to choose. Let's say if I draw a L length like this, what is the area enclosed? Almost nothing, isn't it? It's just L length. L by 2 this way, L by 2 this way. How much we are enclosing the area? 0, isn't it? So this is like a rectangle of 0 width, you can call it. So you change the width, and you have no idea that what length and what width will give you the maximum area. So you will choose some suitable variable. So it's because you have no idea that what is the proper length and width that I should take. How we start with? You give the length and width some variable name. Yes or no?
Yes.
Yes, sir.
So can we call this as X? And this is Y.
Yes.
So what is the constraint here? The perimeter is the constraint, isn't it? See, this rectangle is enclosed by a rope actually. So the length of the rope cannot increase or decrease. So what is the maximum length of the rope available to us? L. So what is the perimeter of this rectangle?
L.
L. And how we can express the perimeter in terms of X and Y? So perimeter constant is L, and how we can express L in terms of X and Y?
2 into x plus y.
So you got the relation between X and Y, isn't it? X plus Y equals to L by 2. Is this clear? And why this is required? Because we want to relate multiple variable, because we just want at the end only one variable. Now, how to write the area? Let's say A is the area. How to write the area? Area equals to.
X into Y.
But you can only differentiate single variable function, right? Oh, yeah, of course, you can differentiate double variable, but can we convert area into single variable function? Yes or no? Can we convert this into single variable function? Yes or no? Oh, I think you're not getting what I'm saying, right? Can you convert into single variable? Means right now we have X and Y two variable. Can you write or express A only in terms of X? Is it possible? Okay, you're not getting. Can we write Y equals to L by 2 minus X?
Yes.
Yes, sir.
See, L is a constant. L is not a variable. So we have only one variable, X. And L by 2, L is a constant. It's a constant quantity. Understood?
Yes, sir.
So let's say it is like you have a length L of a rope and you are trying to create a fencing. Okay. So let's say you have some plot and you want to draw a fencing using the rope. Just for the symbolic that this is your plot and no one should be the intruder or trespasser in that land or property. So L is the fencing. You take L, you create a fencing, and because earlier I was not aware of the dimension, I choose X and Y, and then we realized that okay, X and Y are related to each other. I mean, they are not independent. So using the constant relation, we were able to find the area as a single variable function. Now this is like the quantity that I want to maximize or minimize is now available in terms of a single variable. This is pretty easy. I can write as X L by 2, or L by 2x minus x square. So to maximize, to find the maxima or minima of A, what you can do? So for A max, what we can do? We always differentiate once, isn't it?
Yes.
So can you do on your own and tell me the value of x?
X equals L by 4.
Yes, the same answer.
So you can clearly see the second derivative is negative, which means the idea of maxima is valid here. And we know when x, I choose L by 4, I will get the, what I'll get? The maximum area enclosed by the rectangle. And fortunately, this rectangle becomes square. Because when x is L by 4, the y also automatically becomes what? We know y was how much? L by 2 minus x. So L by 2 minus L by 4, how much? So for a constant perimeter, the maximum area of a rectangle is a square. That's also universal truth, you can remember. For constant perimeter, the maximum area will be a square. It's clear. But this is not the actual maximum area that I can create. With a given rope, what is the maximum area possible for any shape? The answer is circle. So for a given length, we will prove it also. If I choose L as length of a circle as perimeter, and if R is the radius, what is the perimeter? L equals 2 pi R. R is how much? L by 2 pi. So what is the area of circle? Pi R square, which is pi L square by it is coming L square by 4 pi. Let's find the area here. What is the A max here? Here the condition was that I have to create only a rectangle. So what is the A max? You can choose the formula x, y. X we got L by 4, y we got L by 4. You can clearly see it's L square by 16. So which one is bigger, 16 or 4 pi? Which one is bigger? 16 or 4 pi?
The 16.
So which one is smaller, the circle area or the rectangle, the square area?
The circle area is small.
Is it small? Oh, wow. So when you divide something with a bigger number, you get a
Oh, sorry.
bigger number.
Yeah. Circle area is larger.
Large. So for a given perimeter, the biggest rectangle is square. I'm not saying the biggest area is square. Just a moment. Okay. So if you want to, if I give you a finite length rope, and if I tell you that make a rectangular fencing which can enclose the maximum area, the answer is that such area is possible when the rectangle is in the shape of square. If I give you rope and if I tell you, okay, draw whatever you want and tell me what is the biggest area possible to be enclosed, the answer is circle. Okay, so just keeping this in mind, this is a powerful idea. The same goes for the sphere, that for a given volume, sorry, for a given surface area, the maximum volume that you can enclose is a sphere. Okay. So if you want to, if I give you, let's say, some sheet, and if I tell you, okay, make a football of any shape, so that it can enclose the maximum volume, then the shape must be spherical. Then only it is possible. So why maximize and minimize is so important? So let's say you are a product designer. Okay, so your duty is to design a product. So in product designing, we use or consume material. Okay, so the design is already given by the some senior designer, that okay, in this, so in the designing of the product, the base is kept a rectangular shape, or either, I mean, like the base must be either rectangular or a square, of course. And you want to design a product with a minimum cost of the material consumed. So here the material may become the surface area, right? So you're taking a sheet of aluminum to create the box. So the aluminum will cost you something, right? Now the idea is to enclose certain amount of biscuits or cookies or something, wafers. Now those objects which we have already in place, that we want to put into a box. So it goes through a lot of economical, you can say, optimization process, that how to design the shape of the chips, the dimension of the chips, and how many chips that we should put. Because at the end of the end goal is that we must create something which looks bigger and which consumes less material, because the cost will definitely decrease, and the benefit of the cost can be transferred to the consumer. Okay, so the overall uh, product cost will be lesser. So as a designer of product, this concept of maxima minima is very powerful. Now, of course, when it comes to very complex designing, okay, then we use very advanced tensor calculus to derive, and that is like too extremely advanced, that it is like a industrial level designing where the cost is supreme. Let's say if I want to design something made of platinum, and that platinum is going to be used by some NASA rocket. Okay, then by using the least amount of platinum, how to design the given structure, which is sturdy, having the all the sturdiness. It's very powerful. It is not going to break easily. It can tolerate maximum stress, maximum strain. Now that is the extreme of maximum. It's like you are becoming the world best person who can work on optimization. You're that much powerful. You can use various software at your disposal, and then your product are going to be so much powerful that you can eventually become entrepreneur and selling the product to the world. Okay, so now you may ask that, do I know someone like that? So the answer is yes. One of my students is actually doing that right now, and through some discussion I came to realize that, okay, the max minima at a very advanced level called optimization, and they use extreme, you can say, very, I mean, advanced, much advanced than, you can say, master's level. I mean, he did his PhD from the world best university. So he is now designing the optimization, I mean, product, okay, for industrial usage. And recently, this year itself, I think he established his own company in Mumbai. So that's the journey of a student, which I was part of quite closely, and we have been discussing for a very long time. So that's why I'm saying the idea is powerful. Like once you learn something very basic, I mean, once you having the interest in something to explore, you can see this, there is a huge amount of potential to be captured. Okay, Anyway, so maximum minima is not just a problem which is meant for this chapter of physics. It is a way to deal with real life problems. Okay. So imagine I am a builder, okay, and I want to design rooms. So generally, because of the shape of the land acquired by the builder, they design a flat, and definitely they want to minimize the cost of the building materials. Okay. So let's say I'm a designer, I'm trying to design a bedroom, a kitchen. So I want to use the least number of bricks to be used. So now we can come back to the same thing. If we have the, if you look at the perimeter, okay, the perimeter will have finite length, okay, and I want to maximize the area of the rooms. That's the whole idea, isn't it? So a square room is the perfect example. So I will try to create either 10 by 10 or 12 by 12 or 13 by 13, 14 by 14. I'll also try to create a square shaped kitchen. So most of the lands which are developed on a property which is like, I mean, they have a long, I mean, a huge amount of property available. They design most of things square in shape because that will maximize the area with least, you can say, beam occupied. Okay. So they have area maximum with the least perimeter. Okay. Or you can say it's the vice versa. With a given perimeter, how to maximize the area. So the reverse is for a given area, how to minimize the perimeter. So in one way, it's a maximum problem. In other way, it is minimum problem. Because when I construct a building, what I do is I first create the only beams and the outline of the building, right? The bricks are put in the end, right? If you look at the construction site. So the idea of maxima and minima is not confined to just physics or maths. You can see the real life application. Of course, the builder who doesn't know calculus cannot do this. So they go for designers, and designers, hire the best professionals, and they design their building, which actually takes the least amount of material, and therefore a big building need not to be having consuming a lot of material. A poor designing will lead to the lot of consumption of material with poor strength and all. So there are a lot of things. I mean, of course, not all buildings are designed scientifically in a country like ours, because the student, I mean, of course, those who are civil engineers are not too much educated. I mean, they know less about maths. Anyway, coming to the maximum and minimum. So these are some examples just to give you the motivation why we are learning all this. Okay. So now let's say, so you meet another builder who is designing the waterfront row houses. Okay, so in Mumbai, I think Lodha is making actually such row houses in Palava city. It's a riverfront. I mean, they are creating artificial pond or river kind of thing, and you want to design some sort of resort or something. Okay, so let's say this is my river. So river itself is like a protection. I mean, of course, nothing will come from this side. Only some snakes, reptiles can come, but nothing much. So the having the riverfront gives you luxury to design a fencing. So you are trying to have a party by the lakefront or beachfront or the riverfront, and then this is the fencing part. So you again bring the same rope of length L. Okay. But now the rope is supposed to be put only on three sides, because the fourth side is like you want to enjoy. You want to go to the, where you want to go? To the riverfront, right? Or the water body. So now again, the question is like, what kind of shape I need to choose? Like what X and what Y I should choose to maximize this area. I want to maximize this area so that maximum person can be accommodated with the least amount of covering. And what you see is one dimension. Then you can replicate this to make a pandal, something like this, various decoration. So now the question is, with least amount of length in 3 dimensions, this becomes least amount of surface area. The idea is same. Okay. Can you tell me X and Y such that this area is maximum? Can you solve for now? How to choose X and how to choose Y to maximize the area? And find the maximum area now. Enjoy the party. Okay. Are you guys solving this? And I think this is typically the example of football goal post also, right? It is curved from 3 sides only, isn't it? The fourth side is, of course, if you cover it, it's of no use. So how will you start? What is constant here? The total length of the perimeter is constant. So can you express the perimeter now here? What is the perimeter? Tell me. Hello guys, am I audible? Hello, hello, hello.
Yes, sir.
Are you guys solving it? Please answer, everyone. Shreya, Prasansa, Rugved, Siddhant. Are you guys solving it?
Yes, sir.
Okay. Okay, then it's good.
So
Continue.
can you go to the previous slide for 1 second?
1 second. Done. You want more seconds?
Yes, sir.
How many seconds? Anyway, I'll give you 20 seconds. Done?
Yes, sir.
Solve this. Okay, tell me guys, what is the answer? You don't have luxury of writing forever. Okay. So what is the first step? Rugved, tell me. The first step is always use the constant relation. What is the constant here? L. So L equals to
2x plus y.
so I can write y equals to L minus 2x, right?
Yes.
And that will help us in eliminating the variable. What is the area now? Area of the rectangle is how much?
xy.
So we can eliminate x, we can eliminate y, right?
Yes.
So because now a is a function of x only, can you differentiate and solve the answer for x? A is so dA by dx will be how much?
L minus 4x.
So x turns out to be L by 4, right? So if x is L by 4, what is y value? For this x, what is the y? Come on. For this x, what is the y? Use the constant, no? Because the sum of the x and y is like L only. What is y?
L by 2.
Very good. So now you know x, you know y. What is the area? The maximum area? So what is the maximum area? Come on. What is the maximum area?
By 8.
And you can see that it has not doubled from the previous case, right? So just because I gave you a beach front or a river front, now you're parting with more number of friends because you're really happy. You can see the area has doubled. So with the given fencing, the idea to eliminate the one of the side will let you cover double area with the same length of row. That is amazing. And that's mathematics. All hail to calculus, right? Anyway. When I was a student, I remember clearly that when someone was teaching me calculus, I was extremely fascinated by calculus and its ability to answer the real life problem. It intrigued me, I mean, intrigued me so much that I started learning on my own and I finished the entire calculus within, I think, 20 days. And I was ahead of all of the students in my class. It is so powerful, it is so fascinating, and it is like a meditation for me. So I love calculus. So you can also enjoy, I mean, if you enjoy actually, it's like vice versa. If you find something not very intriguing, put more effort. Make sure that you eventually love it. Nothing is boring than yours, like except civics for me. So I was very poor with civics. I never liked, I think, uh, Indian polity. I don't know why. But except civics, if you ask me any subject, I always studied every topic as science only. Even history is science. Geography is anyway science. So I'll tell you history and its repercussion and how we got colonized for almost 200 years by Britishers, just thanks to one invention. Which invention? Can you guess? The invention which colonized half the world population. Okay, you don't know. Steam engine by James Watt. So you can say as a phrase that James Watt ने what लगा दिया. In Mumbai, what do you say? What लगा दी? What लगा दी? Anyway, so I'll tell you the history of this long time. In some topic, it will come for sure. If I'm teaching thermodynamics, I will teach you the entire history. Okay, so we'll discuss about the freedom fight from 1857 to 1947. Next, we can go is a very famous called the sliding ladder problem. So how many of you get fascinated by the power of calculus, that it fascinates you instead of making you it's boring, it's too cumbersome? So rather than this, how many of you get the feeling of it's fascinating? Raise your hand. Just only one. No problem. So Rugved, you don't find it fascinating? No,
Somewhat.
somewhat. Okay. So those who are finding it fascinating, they are actually problem solver. They want to solve something in their life, some issues, some real life problem. So sliding ladder problem. What is this problem? So we have two vertical walls, I mean, one wall and a floor. So Rugved wants to solve the world problem a little bit, not much. Very much happy with the world the way it is. Just joke. Don't take it otherwise. It's just light anecdotes. So we have a ladder now. As the ladder will slip, what will not change? Can you guess? What will not change as the ladder will slip?
Length.
The length of the ladder. So again, the length of the ladder is kind of constant. And now what you can see that this this row, this ladder with this base and the wall is enclosing some area, right? Okay. Let me read through the ladder. So as the ladder will slip, this area will change. So can you tell me the value of x and y at which the area becomes maximum? Find x at which a becomes maximum. So solve using calculus. Of course, we can solve multiple ways, and you can also solve common sense. Okay, so can we relate all these three? I mean, these two variable with the constant. Can we relate? Do you think we can relate this? Can we relate x, y with L? Yes or no, guys?
L square will be root of x square plus y square.
No, that is L, not L square. L square is x square plus y square. That's correct. Yeah, you mean Pythagoras, right?
Yes.
So L square is x square plus y square. This is the constant. Now see, every time the constant will change. And as a first time beginner, and when we start solving problem, the first thing that you will find difficult is, can you really see the constant and can you really create the relationship for a given situation? Okay, so like so far we have been writing perimeter, but now we are not writing perimeter. What we are writing is the Pythagoras theorem. So L square is x square plus y square. This is the constant actually. So you can add y equals to under root of L square minus x square. We just take positive. Now what is the area then? The area will be how much? So area enclosed by the triangle, this rod will be how much? What is A?
Half into x into y.
Correct. And you can replace y as simple enough. And I hope you can differentiate this. dA by dx. We have done all such differentiation. You have to use the product rule. So do the long method. I'll tell you multiple ways to solve, but just do the rigorous way of getting the answer. Differentiate once and differentiate twice. And tell me the answer quickly. So how many of you are more concerned about the unit test of your coaching classes than actually mastering the present topics being taught to you? And if you're doing it, you're doing crime to yourself. You stop trying to prepare or do your best for the next test. Make sure that the topic at present you are mastering it carefully, because physics is all about the beginning. Later on, all struggle will be over if you just master first few chapters. If you try to cover all the tests and if you don't find time to master the present topic, you're making the same classical mistake that everyone does, and no one believes in me. Okay, so they all will agree only after all the harm has been done. Okay. So choice is yours. If you're not solving question, if you're not solving trigo, if you're not solving calculus, if you're not solving vectors, you're doing anyway harm to yourself. Harm that you cannot compensate in less time. It will take the same amount of time. Whether you do today or you do tomorrow, you have to do it, because this is the process by which only you can enter the world of physics. If you try to skip the initial effort and if you think okay, future will be very rosy, sorry. So don't repeat the classical mistake. You never prepare for your test, you prepare for your subject. If you're good with subject, your test will be really good.
Sir, we have to find area, right?
Yeah, right.
I got it as L square by 4.
I think that is correct answer. L square by 4 or L square by yeah, 4, correct. Very good. So dA by dx is how much if you differentiate the first term into differentiation of second term, which will be 1 upon twice of L square minus x square into what is inside the root, which is minus 2x plus under root of L square minus x square and dx by dt, sorry, dA by dx of x is 1. So that means 1. And we are supposed to put this to 0. So what you get here is minus x square and anyway we have to put this to 0. So x square by and if you cross multiply you will get x square equals to L square minus x square. So 2x square is L square, therefore x is how much? L by root 2. And once we have x equals to L by root 2, what is the y value? The y will be also L by root 2. So now the area is half into base into height. And the answer is L square by 4 is the right answer. How we could have done this much easier way of doing this? So this is a ladder. If I say this angle is theta and this is L, what is the base? What is the height? So area we can write as half into base into height. Which is nothing but the L square by 4 sine 2 theta. And what is the maximum value of sine function?
1.
1. So this is the answer. Easy way, right? Without doing any calculus. So can we do something different way? Like I'll just show you like variety of ways in which you can approach a problem. So solving is not important. What is important is like how many ways you know to approach a problem. That is important. Sorry. So we know that half into x into y. If I do, this is like a function called multivariable function. So we can write as dA by dx equals to 1 by 2 d by dx of xy. So you can use the simple product rule. What is that answer? First into differentiation of second plus second to first, which is 1. Okay. So you can actually write the equation like this. Now we know the constant relation. L square equals to x square plus y square. Just I'll show you method so you can approach a problem in multiple fashion. So if I differentiating both sides, so differentiating both sides with respect to x, the LHS is 0 because it's constant. What is the RHS? 2x plus 2y into dy by dx. So what we get here is that Why dy by dx is minus x? So basically I got dy by dx minus x by y. I'll call question 2, then I'll use 1 and 2. From 1 and 2. And I can add dA by dx equals to 1 by 2 into x, and dy by dx is what? Minus x by y plus y. And this I want to equal to 0. Okay. Which means I'll get after solving y square x square plus y equals to 0. And this will give me the only one answer, that y equals to x. It means it is going to be maximum only when y and x are equal. And now we are done. Because y and x are equal, we know the relation between y and x. I can use the constraint. So using constraint, you can get the answer L square equals to x square plus x square. So x equals to L by root 2 is the y. And now, because x and y are known to us, we can find the A max. Okay. And there is no need to do the second derivative test, because in physics, every problem, if I ask maxima, it means only maxima is possible. If I ask minima, only minima is possible. Nothing, I mean, there is no need to worry. So A max will be half into base into height. It's the same answer. I hope this is okay, clear. I mean, it is not something which you have seen much before. This is something which we use in a situation when things are very complex to differentiate. Is this clear, guys?
Yes, sir.
So we have two crossroads, and the crossroads are intersecting at right angle. Okay. And there are two particles. One located here, and this is origin. Now the distance of these particles from the origin at t equals to 0 is given L1. Okay. So what is given to you at t equals to 0? So at t equals to 0, the separation between the particle and origin is given to us. Now, Okay. So question is, you can read the question. Now, if the first particle starts moving with a speed v1 and second with speed v2, then after what time the separation between them will be minimal? So right now you can see this is the separation. That's called D. Better I'll choose. I can choose Z. And what is happening now? That they are moving with some speed. So let's call this is the velocity v1, v1 subscript. And this is so after time t, how much it will travel? Let's say it is traveling very slow. So after time t, it will travel how much? If speed is given, the distance, speed, and time relation, if you remember, distance equals to
Speed into time.
so in time t, the first will travel how much?
L1 by V1.
No, what? How much you will travel? If your speed is v1, so in time t, if this is t equals to 0, this is t equals to t, how much you have traveled ahead?
V1T.
v1. Very good. So your distance from the origin is how much now? L1 minus v1t, isn't it?
Yes.
That is what we are trying to write. So your new distance from the origin will change, right? And the new answer will be L1 minus V1t. Is this clear? Similarly, the particle 2 will also travel how much in the same time?
V2T.
Very good. And if that is the case, then what is your new distance from the origin?
L2 minus V2T.
Excellent. So the distance is L2 minus V2. So what is the new separation? So if I say initial separation is Z naught, the separation at any instant of time t, we know. What is the answer? Z. So we can write Z in terms of Pythagoras. Z square equals to how much? L1 minus V1t whole square plus L2 minus V2t whole square. Isn't it?
Yes.
Now, if Z is minimum, then Z square is also minimum. The square of a minimum is minimum only, isn't it?
Yes.
So to minimize Z, what we can do? To minimize Z, what we can do? We have to differentiate dz square by dt. It's the same thing. dz square by dt because it's a function of time t equals to 0. So now your only duty is differentiate the RHS and equate to 0. Now that is a tough task. I know. So will you try this? So I think you can try it with and Prasansa, you can tell me the answer. Tell me what will be the answer after differentiation.
Sir, here time is constant, right?
Time is the only variable, na? Everything else is constant. L1, V1 is constant. So if you're driving the car at a constant speed, the speed is constant, na?
Yes.
Done, guys? This is difficult. So let me differentiate this. T is the only variable. So we have to use the power rule first. So LHS I will just put 0 on the RHS I can put power rule. So something square is what? If you have some box square and if you differentiate, what we get? 2 times the something into by the chain rule. If you go inside, the L1 will give you 0 and T will give you 1. So this is minus V1. Tell me guys if you're getting this part.
Yes.
Similarly for second term, it's the same rule. And now you can rearrange. 2 will get cancelled, that's common. So what you get is minus is also getting cancelled. So we are getting V1 into L1 minus V1T plus V2 into L2 minus V2T equals to 0. And if you solve, you can get L1 V1 minus V1 square T, L2 V2 minus V2 square T equals to 0. I can rearrange the T terms one side. So V1 square plus V2 square into T equals to how much? L1 V1 L2 V2. And therefore the T we got the answer. T is how much? So after this much time, the separation will be minimum. Do you realize this?
Sir, I had gotten that, but I've thought that we had to put the T in
No,
Z square, so I was trying to
just
put the whole
because
equation.
I'm asking that question only. After what time the separation between them will be minimum? I'm not asking what is the minimum value. So at this instant, after time this much time, the separation is minimum, and this is the right answer. Excellent. If you have got this answer, it's excellent. So this is from you have solved the one of the challenging problem of kinematics. Okay. So I'll just give you some more examples which is pertaining to physics only. And we have done all such differentiation also. So let's say if we have u by v, and if you want to differentiate, and we know the quotient rule which says that it is vu dash minus uv dash upon v square. So whenever you have a function given in the quotient form, and if you want to differentiate and equate to 0, then this will lead to the simple relation vu dash is same as uv dash. So instead of writing in the quotient form, you can just write this relation, because eventually we are trying to equate to 0, and this is going to be the final answer, right? vu dash equals to uv dash. I hope this is clear.
Yes.
So imagine if I give you a function is called e, and e we write as kqx upon x square plus r square power 3 whatever. This is, you can see this is e is a function of x, and x is in the numerator also and the denominator also, which means it is the quotient form. This is a very famous formula in electrostatics, which you will study in class 12th, in which a ring is uniformly charged and this is called the axis of the ring, and r is the basically called the radius of this ring. Q is the charge, which we call charge actually. X is called the distance from the center, and E at this point is called electric field strength. And it is found that if you go or if you move along the axis, the magnitude of electric field strength will vary by a very nice curve which the equation represents. And at one particular value of x, the E becomes maximum. This is the maximum E max. I just want to know the location at which this is happening. So find x at which E becomes so this is your question.
Sir, here we have to find x, right?
Yeah, exactly. Only x.
X equals r by root 2.
Excellent. Wow. So x equals to r by root 2 is the right answer. So, so perfectly got the idea of differentiation and show the maximum. Anyone who actually understands maximum, I mean, you almost command 10% of physics just by knowing this idea. Because every year, if you look at the JEE question, every year at least 2 to 3 questions are only based on the idea of maximum. So the first step is definitely to find the relation, and second step is to maximize the relation. So although it's a very small idea, but if you know it, it's really good for you. So imagine this situation. If I give you a piece of paper and in this piece of paper, let me give you the exact question. Have I shared the maximum number of questions? Maybe. Just a moment, I'll share one more question. Actually, I changed my phone, so I lost all the questions. It's like vanished. Yeah, I think I have shared the. Okay, once again. Okay, you can see it. I have shared something. Open this. Come to bottom. You can see there's a the paper in column 40. The question number 40. So the question is like if we have a rectangular sheet of certain width, I'll just make it in general. So let's say the length is A, the width is B, or vice versa. We have to make a crease by wrapping it. So you take one corner and you wrap it by touching the right edge. So when you do so, it will touch the other surface. I mean, it's like if you bend from here, then this side will touch other side. So it will look like this. So we are just flipping the page. We are, and what do you see? This part is called. Let's name it. So the Q was here actually, and now this is Q dash. The PR is called crease. Okay. The PR is the crease, and we are supposed to maximize the crease actually. So question says that so at what point you must bend, for what value of x you must bend such that the crease is maximum. So P is not the edge, P is the point on the edge somewhere. Do you realize the question? We are just you just take a page and you can solve. So we have to make a crease such that one of the corner is touching the other edge. So as you can see, the Q is touching the Q dash. Okay. I think I can make it better. Anyway, so we have to maximize crease length. That is PR. So how to maximize the crease length? Okay, how to maximize this value? There are many ways in which we can solve. Because this is x, we have assumed this is a minus x, and because this is b, the entire thing is b. But we don't know what is PQ length. So, okay, now what else you can do is if this is x, if you assume this is also x, this is 90, this is also 90. And the length P to Q, if I say this is y, this is also y. Okay, so this is a symmetrical, I mean, this is similar triangle for sure, but that is the page which we have bent, so they are similar actually. Not similar, they are congruent triangles, they are equal triangles. And the crease length is still missing, so let's call this length as L. I want to maximize the L value. How to express the L such that it can be maximized? So that is the question. And uh, the L is basically, if you look carefully, it is again x square plus y square. So I want to maximize the L square. So in a way, I am trying to maximize the x square plus y square. And we need to find some other relation. And you can say one more relation between x and y. So can you think of any other relation?
Area.
No, area is not there. Like we have to express L only in terms of x or only in terms of y. So how to relate y with x without
Y
using L?
equals L.
Without using L actually.
Okay.
We cannot use L. So what you can do, you can do something like this. You can draw a line. So this is y. And this is also y. I mean, I can solve by many methods, but I'm trying to solve using x and y. The other method is quite fancy and very fast. So we can get this answer. Let's say this is so q dash to c. We can find this answer is a minus x whole square plus x square under root. Sorry, this length is how much? The x square minus a minus x whole square, isn't it? This length q dash to c, right? So this turns out to be how much? This will be a plus b, a minus b. Okay, so we got this also, and because this is the entire term is y length. You can see on the left side, PQ is y. So this will be y minus, let's call this as z as of now. And then we can write y, a and y minus z again. Uh, a square plus y minus z whole square equals to y square. So y minus z whole square is basically y square minus a square. So y minus z we can write as, and the z is y minus. So we got z equals to this much, and z is also this much. So we can write, so if someone will solve like this, I mean, of course, eventually we get some answer and we can solve, but this is going to be really cumbersome. So I will not prefer this way of solving. So this is the challenging problem given in this book called Thomas Finney calculus, but we can adopt some different strategy to solve this question with much ease. So we can
So,
solve. Yes,
so
then
can you solve this problem with trigonometry?
yeah, this can be solved by trigon. So we are going to solve by trigon. So that is the strategy. So how to solve it? Because of the similarity. This is x, this is x. If this is y, this is y. If this is 90, this is also 90. So both triangles are congruent triangles, right? You can say ASA, SAS, or whatever, congruency. So if I choose the angle, if I choose this angle as theta, this is also going to be theta, isn't it? So this angle will be how much? Pi minus 2 theta. Clear? So if I call this length as L, so we can write L cos theta as x, and we can write y equals to L sin theta. Okay. So anyway, what we are trying to find, we want to solve in terms of. So eventually we need to express A and B. So we want to express this answer in terms of A and B and theta, not using other thing. So this entire length is A. So if this is L cos theta, this will be how much? A minus L cos theta, right? Isn't it? So we can write like this. Do we really need y? Y is not required. Or what is right? So we can write the formula like cos theta cosine law in this triangle. So using the cosine law, do we really need cosine law? This is pretty easy. This is not required. So A we should write in terms of, yeah, only A will come, I think. A will come. Yes. So cos pi minus 2 theta we can write as in this triangle cos pi minus 2 theta equals to base upon hypotenuse, which is how much? X. And x is how much? L cos theta. So cos 180 minus theta is minus cos 2 theta, which is A by L cos theta minus 1. So A by L cos theta, it turns out to be 1 minus cos 2 theta. So L becomes A by cos theta into 1 minus. Yeah, that is the way we can express L in terms of theta. And now we want to maximize this. You can write L further as A upon 1 minus cos 2 theta is 2 sin square theta. So this is so L max is a similar question than minimizing this term of cos and sin square theta, right? If you want to maximize the L, then the denominator must be minimum. So let Z be the cos theta and sin square theta, and we are trying to minimize this entire term. So D, okay, can I as so dz by d theta, because theta is a variable here. So dz by d theta equals to 0. We have to differentiate 1 and equal to 0. So if you differentiate, what will get? Cos gives minus sin theta. minus 3 cos square theta into minus sin theta. So you can take common. So Z, these are which theta turns out to be how much? This is the value you are going to get. I can take sin theta common. So it's 3 cos square theta minus 1. Yeah, it's opposite. And if you equate to 0, that 2%. Either sin theta is 0 or 3 cos square theta minus 1 is 0. This will give you theta equals to 0, which will have no meaning in the problem. Okay, so that will be ignored or cancelled. But the other is meaningful. That cos theta is 1 by root. And now we're done. So the Z minimum we are going to get is how much? Cos theta into 1 minus cos. So the L max will be A by Z minimum, and assume this is Z minimum only. So this is the answer, 3 root 3 by 2 into A. So the maximum crease length that you can achieve is this much. Of course, it requires some practice to understand questions like this. It's not easy. You may look at the solution 2 or 3 times, try to understand, and in case if you're not getting it much, you can ask me again. If you're getting it, it's really big. So with time, all these things will become easier for you. So everything which appears difficult now will not be difficult in the future, because there is a settlement time for the brain. So concepts are like dust. It takes time to settle down. So whether teacher is saying, okay, you must understand everything, you also say yes in the class. We know that inherently that you have understood, but not you have realized. So from the understanding to realization is the hard work which you pay at home. So our job is to make you understand. Your job is to make you realize. I mean, realize for yourself. And that is the journey. In that journey, effort is required. And if you put effort, once you realize, it becomes your part. It's part of your memory, and you can play with such idea in future. So whenever we start learning any topic, not physics, chemistry, maths, any topic, the process remains same. Try to realize things slowly. And if your brain is taking more time, and if the class syllabus is going really fast, don't try to match the syllabus, try to match the brain. Because everyone is not supposed to finish everything in the 2 days time or 1 day time or 1 week time. You prepare as your brain deem fit. If your brain is saying that no, I will take 1 more day to finish, take 1 more day and finish it. That is the strategy for long-term gain. So the final examination you are not going to write today, right? So don't get bothered by the marks which you are getting. These things really doesn't matter. But if you have the right way, the marks will start coming after 5 to 6 months. And in the race, you will be much ahead of others. So in the beginning, just like every good batsman, what they do is they go to crease and they don't start hitting runs. If it is a test match, they play a lot of balls. They try to understand, realize the condition of wind, how the bowlers are throwing their ball, how it is turning. And once they realize everything, they start hitting. They start slogging. And then they only create the big scores. The same is true with studies also. Be like a batsman. Don't try to hit every ball. Try to realize, stop the ball, defend it, and make sure that you understand it at the end of the lecture. And then you put effort to realize it. So from the understanding to realization is your journey, which I expect that you will be doing with all the sincerity. And then the result will come after some time. So don't worry for the result. You have sufficient time. Those who come to me after 2 years, in fact, after 1.5 years, they come like 6 months before the examination. They also qualify JEE because they have already mature brain and they realize things. So all the mistakes they try to rectify and eventually they qualify. You have sufficient time. So if you don't make mistake from right now, your potential to score a very good rank is very, very high. I mean, you are anyway going to qualify, but I'm seeing the rank. You may go within the rank of 100, 200, or 300, or maybe under 500. So for that rank, no need to be extraordinary. I mean, of course, we are not supposed to be a genius or born with some child prodigy. We are not supposed to do any of this. We are supposed to only work hard and consistent and the right strategy. That you learn something, you make sure that you understand, you realize, you make your notes, you read your notes carefully, you revise regularly, some small stuff, and practice as much as possible. That will make you extraordinary in the span of 1.5 years. And you will feel all those things, what I'm saying right now. You will feel that you have become powerful. You have become much ahead of many students because you have kept the strategy correct. So from high school, what happens nearly in class 10th, the strategy which you acquired there to learn the science, that will not work here. Please do not apply. If someone is applying that, okay, no, I'll mug up something and we'll write the good test, we'll try to get good marks, we'll make many flukes. Because you are so much concerned about marks that you fail to understand the concept. If you start concerning about your concept, not marks, eventually marks will start pouring in a huge volume. Don't worry. So I can tell you the IIT All India rank 33 Aman Goel, I think who qualified in 2017 or before, I think 2016. He was not the brightest. He joined almost 6 months late in a coaching. And in the first 6 months, he was much behind everyone else. And then he became the city topper at that because he said the same thing. I never try to, write a good test. I would try to understand the concept. So if something was taking more time, I was giving more time. So I was making sure that everything, every concept I have really understood in a way that I can recall, I can remember. And when almost 7-8 months happened, when the final test started in the month of October, there in the first few tests he was not scoring much, but suddenly he realized his mistake, that what he was making the mistake consistently. He removed everything. And from the third or fourth test onward, he was the topper, consistent topper. He never went second also. And then he became the city topper, got all India rank 33. He studied in IIT Bombay, and now he's entrepreneur, running his own company. So a very mediocre student. He was not the brightest child. He was just a mediocre student. What really matters in JEE preparation, which I have seen, the intelligence will have a role, definitely, but only 10%. 90% is hard work, consistency. So don't think that, okay, someone answering the class first is the brightest student. No. There are many secrets behind their answering the question. They might have the notes from the senior. They might have seen the answers. They might have, done this problem before and they are able to answer. It is like they have rehearsed and they are reciprocating the dialogues. It doesn't mean that they are the brightest actor, and you're in the process. You have not rehearsed anything. And in the final examination, when the new script will be given to you, then the real talent will come. If the script is available to you beforehand, you can practice, rehearse, and get a good marks. What if there is no script known to you in advance? So there the skill comes. And that is why many students who perform really good in coaching institutes examination, they do not perform really good in the final examination. That is the trend. And many mediocre students, they qualify with the best rank. In fact, IIT 2009 topper, I think Agrawal, Nitin Jain, yeah, Nitin Jain. He was the topper and he was the worst student in his class because he was not studying. I mean, he was having masti and all for a long time. When he started studying sincerely, so first 3 months he was the poorest student in the class, not able to answer a single question. Then after that, when he started studying, being in the lower batch, he was not the student of topper batch because he was not able to match the sports syllabus with his own preparation. So he was always getting less marks in the examination. But whatever chapter he completed, he was very good at those chapters. The only difference was other were ahead of him in terms of completion. He was behind. But when he finished those chapters, he was much better than others also. So eventually got all India rank 1. Imagine. Preparation is done with our own skill and our own estimate of knowledge, understanding. Don't try to compete with others. Of course, try to do better for yourself. You eventually will compete. In the beginning, my session to all of you, stick to basic, derive, define, remember the definition, know the derivation, and then come to the result. Keep this strategy intact. Trust my word. Nothing will go beyond beyond my words. Nothing can go actually. Okay. Whoever is saying anything, just ignore. Your past experience, your friends, your colleagues, your friend, your cousins, don't listen to them. Okay, because being a teacher, I have seen thousands of students. Your cousin must have met only few hundred or maybe few countable students in his life. So my sessions are much more generalized than anybody's session. So what worked from them will not work for anybody else. As a teacher, we have a very generalized perspective of everything. So when I say do this, it means in general, if you work this way, the success is guaranteed. Okay. So one particular way of getting success is not a general way for everyone, but the way I am saying is a general way. Everyone can get success if they will follow these rules. The history is the testimony for the same. Okay, let's do some question before we end today's lecture. And this will be the end of the maximum minima. We'll go for some other concepts. If you have understood the basics, you can practice from the sheet which I have shared, and then you can ask doubts. So I'll again keep one separate doubt lecture for differentiation and maximum. So imagine we have a tank which is filled with water. The total height of the tank is h. And from the top of the tank, we make a hole. And as a result, water starts coming out as a fountain. And the water coming here will hit the floor. And this height is, that's called small h, or I can take from bottom. So at a height h, you make a hole and then you see the water jet coming at some speed and hitting the floor. If I call this distance as z, from the laws of physics, you will come to know later on that z turns out to be a function like this. Small h into h minus h. Small h is a variable. And as you change the small h, the z will change, and it is given by the function as shown here. The question is, for what value of h Z will be maximum. So how many of you feel the pressure in the class that many are answering the question you are not able to answer, and you feel really bad about it? How many? Prashant, do you feel bad when you don't answer?
Or sometime.
Shreya and Rugved, how you
Sometime.
feel? Sometime. And that feeling is not bad. That feeling is very genuine. Every good student, they feel. But when you feel bad, don't try to, go home and start mugging up the formula. You go home and try to understand why we are, why you're not able to answer, which kind of formula you forgot, and how we can derive the formula. Again, when it comes to formula, don't try to remember it, try to derive it. And every time you forget, every time you derive. This habit will help you in remembering the formula for long, long time. Because you know the basic, you know how to derive it. So in a way, it will take away the burden of remembering the formula. So these are small tactics, very small tactics. It's good to feel bad, but it doesn't mean that okay, you will stop studying. It means you will take more time than the brightest student in the class who is answering everything. The only thing is you will take more time. The time is the only constraint for you. So by putting more effort, you can reduce the time. And eventually, if you are really good with the topic, in the long term, you will be the winner. Tell me the answer for this. So what is the Z value? Sorry, what is the H? What H will make the Z maximum? It's pretty simple. You can square both sides and differentiate. That's easy, right? So what we need to differentiate? dz by dz by what is the variable here? Input variable is z is a function of what? Which variable will decide z?
Small h.
Excellent. So you must differentiate z with respect to small h. So dz by dh is 0. Is this clear?
Yes.
So how much you getting?
Capital H by 2.
That's the right answer. Right? So it is called the midpoint. If you make punch a hole at a midpoint, the range becomes, this is called range actually. So the range becomes maximum when you punch a hole at the center of the tank. So the water will go maximum farthest point, farthest from the tank. Okay. So again, everything will have some role. I mean, somewhere in physics, you are going to use this. Okay.
So can you please explain how you did the calculation?
So you can write z square equals to how much? H minus h square. If you differentiate it, do z dz by dh, the first one will give you h, second one will give you 2h. And if you put to 0, because if this is 0, everything is 0 only. Understood? Got it now?
Yes, sir.
Okay. Okay, so with this question, I'll end today's lecture. And now, as a homework, the PDF which I've shared one PDF today. You can see. So I want you guys to start solving few questions at least. So your homework is up to 10. Just try the 10 questions. See, if you make a small goal, everything can be achieved. So your homework is not all sheet, only 10 questions. So make sure that you start today and you finish the first 10 questions as soon as possible. Okay. So just 10 questions for today. And then every day you make sure that you solve 10 to 20 questions of physics, and that will be sufficient to master physics. But every day, if you make a gap of 2 days, it is now 20 to 40 questions. If you make a gap of 3 days, it is now 60 to, 30 to 60 questions. So if you make a gap, then it will pile up. It will become huge. Consistently, 10 to 12 questions is sufficient to finish any book with ease. So I used to solve 10 questions per day, and then I finished in 100 days, 10 to 12 actually. So I think I finished 1291 questions in 100 days, exactly 100 days. So roughly I solved 1300 questions, and all the 1300 questions were Olympiad level. It was not a Varmaji or Erodab level. Much difficult than Varmaji and Erodab. So for you also, if you just solve regularly 10 questions, first of all, the effort will be less. You will not get burdened by the homework. And every day will improve. So today solve 10, next day solve 10, 10, 10, 10. Don't count time. When you're solving question, don't think of time. The first step is time is not a constant factor. You can reduce your sleep, you can do whatever you want. Keep on solving till you are finding it easier to your brain. All right, guys, see you in the next lecture on Friday. And on Friday, we'll start dy by dx as a rate measure. So you have seen this in bits and pieces. You will see concretely as a topic called rate measure. Okay. See you in the next lecture.